let f be a function such that f of negative 1 is equal to 3, f prime of negative 1 is equal to 5. Let g be the function g of x is equal to 2x to the third power. Let capital F be a function defined as, so capital F is defined as lowercase f of x divided by lowercase g of x. And they want us to evaluate the derivative of capital F at x equals negative 1. So the way that we can do that is let's just take the derivative of capital F and then evaluate it as at x equals 1. And the way they've set up capital F, this function definition, we can see that it is the quotient of two functions. So if we want to take its derivative, you might say, well, maybe the quotient rule is important here. And I'll always give you my aside. The quotient rule, I'm going to state it right now, and it could be useful to know it. But in case you ever forget it, you can derive it pretty quickly from the product rule. And if you know it, the chain rule combined, you can get the quotient rule pretty quick. But let me just state the quotient rule right now. So if you have some function defined as some function in the numerator divided by some function in the denominator, we can say its derivative, and this is really just a restatement of the quotient rule. Its derivative is going to be the derivative of the function in the numerator, so dx f of x, times the function in the denominator, so times g of x, minus the function in the numerator, minus f of x, not taking its derivative, times the derivative of the function in the denominator, dx g of x, all of that over, so all of this is going to be over the function in the denominator squared. So this g of x squared, g of x squared. And you could use different types of notation here. You could say, instead of writing this with the derivative operator, you could say this is the same thing as g prime of x. And likewise, you could say, well, that is the same thing as f prime of x. And so now we just want to evaluate this thing. And you might say, well, how do I evaluate this thing? Well, let's just try it. Let's just say, we want to evaluate f prime when x is equal to negative 1. So we can write f prime of negative 1 is equal to, well, everywhere we see an x, let's put a negative 1 here. It's going to be f prime of negative 1, f prime, lowercase f prime, it's a little confusing, lowercase f prime of negative 1 times g of negative 1, g of negative 1, minus f of negative 1, f of negative 1, times g prime of negative 1, g prime of negative 1, all of that over, let me do it in that same color. So I take my colors seriously. All right, all of that over g of negative 1 squared, g of negative 1 squared. Now, can we figure out what f prime of negative 1, f of negative 1, g of negative 1, and g prime of negative 1, what they are? Well, some of them they tell us outright. They tell us f and f prime at negative 1. And for g, we can actually solve for those. So let's see. If this is, well, let's just first evaluate g of negative 1. G of negative 1 is going to be 2 times negative 1 to the third power. Well, negative 1 to the third power is just negative 1 times 2. So this is negative 2. And g prime of x, I'll do it here. G prime of x, which use the power rule. Bring that 3 out front. 3 times 2 is 6. X, decrement that exponent. 3 minus 1 is 2. And so g prime of negative 1 is equal to 6 times negative 1 squared. Well, negative 1 squared is just 1, so this is going to be equal to 6. So we actually know what all of these values are now. We know, so first we want to figure out f prime of negative 1. Well, they tell us that right over here. F prime of negative 1 is equal to 5. So that is 5. G of negative 1. Well, we figure that right here. G of negative 1 is negative 2. So this is negative 2. F of negative 1. So f of negative 1, they tell us that right over there. That is equal to 3. And then g prime of negative 1. Let me just circle it in this green color. G prime of negative 1, we figured it out. It is equal to 6. So this is equal to 6. And then finally, g of negative 1 right over here, we already figured that out. That was equal to negative 2. So negative 2. So this is all going to simplify to, so you have 5 times negative 2, which is negative 10, minus 3 times 6, which is 18. All of that over negative 2 squared. Well, negative 2 squared is just going to be positive 4. So this is going to be equal to negative 28 over positive 4, which is equal to negative 7. And there you have it. It looks intimidating at first, but if you just say, okay, look, this is, I can use the quotient rule right over here, and then once I apply the quotient rule, I can actually just directly figure out what g of negative 1, g prime of negative 1, and they gave us f of negative 1 and f prime of negative 1. So hopefully you find that helpful.